Okay, so we are going to do some of these examples now that have to do with those different types of weak acid problems. All right, so I'm going to read example number 1. A solution that is 0.012 molar in nicotinic acid, that's the acid based on nicotine, has a pH of 3.39. What is the Ka for this acid, and what is the percent dissociation? So let's just look at what we have and what we're trying to find. Okay, a solution that is 0.012 molar. Now, this means that is my initial concentration. Okay, I never know what it is, what the concentration is at equilibrium unless I literally say at equilibrium, but this is like what I put in. So that's always an initial concentration. Now, if I have the pH, like I actually measured that, that would be at equilibrium. Okay, so that might be kind of hard to distinguish, but essentially if I give you the concentration, that is an initial concentration. That's what I made up. And then if I measure the pH, that would be at equilibrium, because once it's reached equilibrium, that's when I measure the pH. Okay, so kind of try to keep those straight. And then I want to know Ka, all right? So we know the Ka equation, right, is going to be, essentially it's x squared over whatever my starting concentration is. In this case, 0.012 minus x, okay? It's always going to look like that, all right? And in this case, we will probably be dropping the minus x, but I'll show you how to double check that. So what I'm going to do is, I know this is a weak acid because it's not one of the 6 strong acids I had to memorize. Now, I don't know the formula for nicotinic acid, so we just call it HA, make our lives easier, okay? HA plus H2O, that is my Ka equation, makes H3O plus and a minus. I'm going to make my ICE. Okay. I know I started with 0.012 of this acid. I don't care about the water. 0, 0, minus x plus x plus x. Now, after a while, you guys probably won't have to write out this whole ICE table because you know it's going to be x squared over 0.012 minus x. But in the beginning, it's important, especially when we start throwing in, maybe I had some A minus in there to begin with, so that'll change things. Okay, but if I were to write out the Ka equation then, looking at this, right, it's x over 0.012 minus x, just like what I said before. So I'm going to combine those terms at the top, so I get x squared over 0.012 minus x. Okay, so I'm trying to find Ka, and I have the pH, which again, the pH would be at equilibrium. So that means I can find from the pH, I can find my H3O plus, right? It's going to be 10 to the negative 3.39, which is 0.000407738 or something like that. All right, now that is my H3O plus concentration. So that is x. So I could actually plug this in. I don't have to do any of that dropping x because I know x. So it's going to be Ka equals that number squared, so 0.00407, you can keep more sig figs if you want to, over 0.012 minus 0.00407. All done. Plug that into my calculator. Make sure you do the squared up there. Don't forget it. And you can do the subtraction when you know what x is. You're going to get 1.4 times 10 to the negative 5th. And remember, K values do not have a unit. So that's a pretty small K. Makes sense. Weak acid. Great. All right. We're going to do example number 2 because instead of asking for Ka, this one wants to know the pH. Okay, so different type of question. Now remember, pH would be at equilibrium. And from pH, we can get H3O plus. Okay, so remember, those always go together. So I have HC2H3O2, which is acetic acid. What is the percent ionization? So remember, to do this, I'm looking for X, whatever X is. All right. So I know this is a weak acid. I know I got to do ice. So I'm going to go ahead and write it out. HC2H3O2. Now I'm going to start dropping the water part because the water part doesn't matter. And so instead of writing that whole thing, I can actually just do H plus and C2H3O2 minus. Both are appropriate, this equation or including the water. And you can do it this way too. Same thing. All right, so I got ICE. I'm starting with 0.10 molar. Got that from the problem. 0, 0, minus x, plus x, plus x, 0.10 minus x, x, and x. Awesome. Okay, so I got Ka is going to be x squared over 0.10 minus x. Awesome. Now I'm trying to find pH, which means I need to find X. I need to find this value here. Now, I didn't actually give you this in the problem. I would if it were a problem on the exam, but we're going to look up, we know it's acetic acid, so I'm going to look up the Ka value for acetic acid on my sheet, and it is 1.8 times 10 to the negative 5th. So I set that equal to x squared over 0.10 minus x. Now, you can use your solve button. If you got a TI 89, go for it. That's great. You're going to get the x value. Now, you'll get 2, remember, but one of them is too big and you'll end up with negative numbers. You can't have a negative molarity. So the smaller one is going to be your answer. Now, that being said, this whole dropping x thing, if I drop this, that'll make my calculations a lot easier. And since it is a weak acid, I can probably drop this. So I'm going to drop it. So now I've just got it equals x squared over 0.10. Easy algebra, multiply by 0.10, take the square root. I would get that x is 0.0013416. Awesome. I can plug that in here. I know that's H plus, so I can find pH. That will be the negative log of this number. So the pH ends up being 2.87. Okay, now if you did want to check, was it okay that I dropped that? Check that 5% rule. Is X less than 5% of your starting concentration, 0.10? Well, 5% of 0.10 is what, 0.005? And yes, this is less. Okay, no, that's not 0.005. I didn't do my math correctly there. Yeah, I did. I was just double checking myself. Okay, so it's 0.005. This is less, so it was okay to drop that X. Now, if you did it in the solver in your calculator, you probably got a slightly different number for X. You're going to end up with about the same pH. So dropping X, okay, in this case. And I got 2.87. Does that answer make sense? Well, this is an acid. Sure, 2.87 sounds about right. It's a weak acid, so it's not like 1 or anything like that. So this was probably correct.